All right, let's get started. All right. Okay. Oh man, I'm always mess with my audio. What's up, Ethan? Bum, ba-dum, bum. Live on that. Y'all tell me if my audio is okay. I'm experimenting with a lot of things, trying to get rid of. There's a lot of like background hum noise I'm getting when I try to do messing around. Always, it's just like sample rates and bit depths and. Right. I can hear you. Yeah, I can hear you, dude.
Hi, how are you
Good, man. It's Friday. How's your Friday going, dude? What's up? How's Friday?
doing? I had a free day today
Free
since it's
day.
Teachers Day.
Nice. We love the teacher days.
Also, I know maybe some people would say this for you, but Happy Teachers Day, even though you're technically not a teacher.
Oh, dude, I appreciate that. I think it's also like Happy Nurses Day today in the U.S. I think it's special nurse day.
I never
Or
heard of
maybe that
any
was yesterday.
special Nurses Day,
Maybe it was.
but I'm
Uh,
saying you're still a great tutor or teacher,
I appreciate that, dude. Yeah, teachers come in all sorts of shapes. There you go. All right, we're live
and their
on,
emotions.
and their emotions. Yeah, emotions too. There's a lot to that. A lot. Okay, we're live on that. We're live on that. Let's see if TikTok wants to be
You
nice
always,
with.
you always want to be live on TikTok now.
I want to be live on everything because, like, everyone can.
Also, are you gonna do another physics stream on Saturday and Sunday?
I think I will actually with Noise. He has an exam coming up, and I think I'm gonna go through one of his practice exams. Help him out. I think that'd be. All right, you liked seeing the other physics.
Yeah, but then like they were a little confusing for me. What if you
Yeah, it's
what
okay.
if you teach me but what if you teach me the first thing? Like what people usually take in physics first. Then they start
Yeah,
going advanced.
yeah, no, exactly. You know what? Did you ask a question in office hours? I can do like a basic. Wait, how did your Pythagorean theorem quiz go? Head on Wednesday.
Uh, Sorry, I apparently I didn't take that today since they shortened the classes.
Oh, okay.
Because we had a spelling bee we all had to go to a spelling bee in the church.
A spelling bee. That's fun. We had spelling bees when I was in those.
Honestly, I do love
It's
spelling
kind of
bees.
it's a funny thing, right, to have a spelling bee because nowadays we just have autocorrect for everything, right?
No, I mean it's not online spelling bee.
No, I know it's in person where like someone has to go up there, they like say a word and then they got to spell it correct. I know what it's all the time. I was in elementary. What's this bot?
So you can teach me some basic physics stuff.
I can, yeah. Let me do that. Oh, I see. Yeah, because you gave just like a weird math question, right? Right? You
Another
gave like
one
a
of those.
challenge math question. That's what you gave me. Yeah.
Yeah, because honestly, I feel like the Pythagoras
Yeah,
theorem
you
is
already
a
know the
little too
Pythagorean
easy for
theorem.
me.
It's a little too easy. Exactly. That's great. I'm glad that you. That's good. We love that. Okay, cool. That started. I'm always like, where am I forgetting to do? I got it. Yeah. Okay. Nice. Okay. That and then Riplaw. Yeah, Riplaw can speak. Good. Okay. Awesome. All right. Let's start the stream off. I need to get like one of those cool intro video things. You know where they do like the or something. I might make one over the weekend. Anyways. Okay. Cool.
Maybe.
Welcome everyone to Office Hours. My name is Dr. Gold. Actual Education, the stream that helps you out with your math homework, science homework, even just like learning new stuff. You know, Ethan brought up a good. So last weekend we did an AP Physics review. For the students.
Two times in a row for the days.
Yeah, we did. We did it Saturday and Sunday. Yeah, I did a lot of streaming, which is cool. But yeah, and that was mainly more of an advanced type of review for people who kind of already taken physics and needed some help on like how to get through some of the free response questions on the exam. But we had some other students that watch it. This is what I love about even if like we're doing something advanced and you don't know it, you still get curious about it. You'll learn. You learn a little bit like just so yeah, that's what we did last weekend. Actually, let me see. We had a lot of people. I think we had almost like 150 views on TikTok. That was pretty cool. Big fan of that.
No, that's way too much.
That's way too much, he said. Where's my stream? Yeah. I remember seeing like my analytics here, dude. I was like, it's like pretty cool.
Also,
there's so much streaming these days. You know, we didn't have as many viewers on the Saturday and Sunday, but that's okay because it was mainly for people who were in the Discord. They weren't watching in Twitch. They were watching on Discord. Oh, you know what they needed to do? Noise is now Noise. Wait. What's your? Yeah, there we go. Noise
baby.
Noise baby. Cool. I'm gonna make him a moderator. Mod art.
Wait, why can't you give me one of those, huh?
You are
like,
there.
I've been in this...
Yeah, aren't you in there? Or have you changed it here? I'll go. What is it? It's Ethan, right?
What if you made me at least a VIP? Maybe make.
No, I'll make you a mod. You're okay. Ethan Quello, what? 20. What's your 2913? Is that 2912 or 2913?
291. It's 2913.
Okay, cool. I got you. Or moderator. All right, cool.
Thanks.
Nice. Cool. Yeah. No, I always appreciate. I'll make an announcement in the Discord, but yeah, I promoted Noise to associate class rep because he's been very helpful lately. I really appreciate Noise. All the help you gave with Grim yesterday, for instance, on logarithms and whatnot. That's a great way to help out. And you've been very reliable, and you've been active, and you haven't started any fights. I love it. So yes, congrats on being mod.
I have never started.
You have never started a fight either. Yeah, no, I appreciate that as well. Yeah, that's why you keep your mod.
Fights.
Yeah, it's not good to get in fights. You know, it's better to deal with things amicably. You know. Tika says I've started many fights. Yeah, GG Noise. And Noise is also he's offered to help code a Discord bot for us, which I'm really happy about that. That's gonna be really cool. So expect some really cool things from him coming up.
Also, Dr. I want to ask some stuff.
Yeah, what's up? What do you want to ask?
How many physics are there? Like, is there like a physics Sunday or AP physics? Like, is physics and AP physics different?
Yeah, no, this is a good question. So actually, Riplaw asked this. He said, "What is AP physics?" Very good, very cool. Okay, so physics can kind of be broken down into a couple subjects that you study. There's what we call mechanics. Okay, and this is like the study of moving things. Is what I say. So, such as like ball. What's up?
Isn't physics like calculating velocities and stuff?
Good. Yes. Yeah. That's one side of physics. Physics is like the study of like how things move and interact in our world. I think that's like the technical. But Teacup, you're welcome to help as well. I need everyone's input on that. Noise took the initiative and like literally created a bot for me to invite, and I was like, okay, cool. Anyways, so physics, yes. Mechanics, which is moving things, balls moving in the air, collisions and whatnot. That's one side of mechanics. Sorry, physics. And then what we have,
What's collision?
with collisions, like, you know, if like a train collides into like a car, and like how do they move, or like if a bouncy ball, right, hits the ground and does stuff. Mechanics equals kinematics plus dynamics. I like that, dude. Yeah, that's a cool one. Bonner Freunde. Yeah, dude. I like that. There you go. I'm gonna pin your message. I like that. Yeah. So mechanics is one side of physics that comes up, and I'll go into like what the courses are for these. Then we have E&M. This stands for like electromagnetism is what it is. And then this has to deal more with like electric fields, electric magnetic fields. We say forces on particles, things such as electric potential, which you guys know probably, right? Voltage. You guys know you've heard of things like voltage. This also goes into like circuits. Sometimes we got like circuits. That's like the resistors and the batteries. So that's another section of physics that gets broken up into a class. And then they kind of usually do like this, what I call like the grab bag, grab bag of modern topics. And this tends to include things such as waves, thermophysics, thermodynamics, and a little bit of quantum. A little bit of quantum physics kind of gets put in this like grab happens.
I don't know what
Oh,
you're saying.
there's so much physics.
Yeah. Okay. So waves is like sound waves, right? You guys know what sound waves are, right?
No.
Yes, you guys. Yeah. Like or like you've been in the ocean. There are waves in the ocean, right? You know.
Yes.
Yes,
Yeah,
you are.
there are waves in the ocean. Yeah.
Yeah, that's an example of a wave. Thermodynamics has to deal with like heat and like temperature and stuff. So this has to deal with the physics behind, you know, how long it takes for you to boil water or to heat up a room or to like cool down a car. Like that's all thermodynamics. And then quantum is kind of like, that's like some weird stuff that has to deal with some sort of like, sometimes we get into relativity there, like time dilation, length contraction, particle stuff, Schrodinger's equation, a bunch of stuff. Yeah, don't worry about this stuff. This is you'll get to it at some point. But anyways, that is generally what physics gets broken up into, and there are courses associated with it, okay? Usually this is Physics 1, this is Physics 2, and then this is Physics 3 in kind of the university sense. They'll usually offer it in 3 different courses. Sometimes they'll blend these two together, or they'll, they try and like split it in half.
All right.
Yes. And then in terms of what Riplov was asking about, what is AP Physics? So in high school, you take a regular physics course, okay? And then you can take what's called like kind of like an honors physics course. Do you guys have that, Riplov? Do you have like honors, like pre-AP or something?
Honor roll or something like that?
Well, let me think. You're in what, 6th, 7th grade, right? Or 8th? I forget.
Yes.
Yeah. So do you guys have like a math class, and then you have like a more advanced math class for like people who like want like harder stuff?
I'm not a smart person, so I don't get that stuff.
It's okay. No, you're all smart people. But I'm saying in your school, do they offer that? Do they have like, it's like GT, also gifted and talented is what they used to call it in my year too, right? Probably, yeah. And then they can do AP. Yeah, Bob has a good point here. Yeah, so usually everyone can take like regular physics is what I say. So it's like regular level physics. It's not like super advanced and whatnot, but it's to get you introduced into it, okay? And then what you can then take afterwards is a more advanced version of physics, which is called AP Physics, okay? And AP stands for Advanced Placement, okay? All this means is it's a fancy word for it's a harder class, and there's a test at the end of the year they call an AP exam. And if you do well on the exam, when you go to college, they give you credit. They give you course credit. Like, you don't have to take that class again in college because they say you did well enough on it on the AP exam in high school. So it's incredibly beneficial because it means you save money. You don't have to pay for that course in college. And then also you can kind of leapfrog into more advanced classes is where that works. F equals MA, it's all I remember from freshman year of physics, yeah. So AP Physics 1 tends to do, I think it's just this, and it's algebra based, which means they don't use any calculus in it.
Algebra?
No, it means they only use algebra. So in physics, you have to do a lot of math in order to solve problems, and there are different levels of math. Pardon?
It is heavily relied on math. Like
It is.
physics has
It
a lot
is.
to do with math.
Lot to do with math. You know, if they ever like, have you ever seen like I'm sure Noise has seen this, like the hierarchy of sciences, right? Have you seen this one?
Why? You know why couldn't physics be a math subject and not
But they
science
think
subject?
astronomy is what is this, dude? They really put this. This is the one I would. I want like a cool picture of it. The hierarchy of science, because all the sciences are kind of derived on each other.
Gold, when you have time,
Yeah.
can you
Okay.
watch the video I pinged you to?
Is it about science? What is it about?
Fortnite, and why I really love this game. It's
Oh,
10
okay.
seconds.
Cool. Yeah, I'll check it. I'll check it out.
So,
Yeah. This is
why couldn't
this is the math is the language of physics. Yeah, exactly. You're so right, Barnard. Yeah. So this is kind of the big pyramid they talk about it. Yeah, math is down here. Yeah, math is like the
why
most
does it
core
have to be
science.
all the way down?
What's up?
Why does it have to be all the way down there?
Okay, good. So how this works is we say that physics is applied math. Okay? So what that means is that like physics takes a lot of math concepts and applies them to the real life movement of things. So for instance, in physics, there's an equation that describes the position of something if you throw it in the air. It's called a kinematics equation. It has to do with this. V naught t plus 1/2 at squared.
Okay. This is already getting confusing.
It's okay. This is an equation, but you see how this is math, right?
Mm-hmm.
So this describes the motion of an object, which is cool. So that's a real life thing. That's a physics thing, right? Like the motion of.
So what
like,
do these mean? What do these mean? Like
I'll
the
get I'll get into it. Yeah, but I just want to show you that that's a math equation, right? So physics takes math and applies it to the real world in some sense. Yeah, exactly. Yeah, and you had to use it in calculus. Yeah, cool. And this actually comes from calculus, because what we say is that v is equal to dx dt and a is equal to dv dt. You can actually, from calculus, from math, from just this equation in math, you can derive this. You can integrate twice and get to this. It's very cool. So this is why we say that physics is applied math. Like, math does all these cool things with numbers and curves and whatnot, and physics takes that and applies it to do its own stuff. Yeah, the equation is pretty cool. It is pretty dope.
But you know what
dope.
else?
What's up?
Like, why can't physics just be math? Because if it has a lot to do with math, it should at least be in the math subject, because there's barely any science in it.
Well, no, there is a lot of science to physics. So this is the cool thing, is that so physics uses a lot of math, but then has concepts you have to know that aren't math related. And some of those are, for instance, like conservation of momentum. You know, that doesn't really show up in math as an equation. That's just something we know. We know that the momentum of something before has to equal the momentum of everything afterwards. That's a physics concept. That's something that isn't baked into mathematical equations, but we know that in the real world. We just use math to help that. So physics has a lot of theory to it that uses math, but doesn't strictly come from math. Variable acceleration, yeah. No, it's nice. You know, do you know what variable acceleration is? Do you know what like dAdt is? You know what the derivative of acceleration with respect to time is? It's actually it's called jerk. They call this jerk. It's actually it's a real term. I shit you.
No way. Come
It
on.
is, dude.
Seriously?
You guys don't believe me, dude? It totally is. Jerk accelerate. Look at this. Yeah, jerk. Yeah, this is it, dude. Look at this. Yeah, dude, I love this, dude. So velocity is the change in position. Acceleration is the second derivative of position. Jerk is the derivative of acceleration. Then you have snap, and you have crackle, and then you have pop. Physicists are funny, dude. They sometimes they just come up with jokes. They're just like, oh, let's just make a joke in here, dude. Like, yeah, because like, yeah, no, it's serious. Yeah, dude, like snap, crackle, pop, like the sixth derivative of position. Because like, why would you need the sixth derivative of position? You know,
What can I answer?
I wonder who did come up with it. Yeah, what's up, dude?
There was something natural with me.
What's up? What's up? What's up?
Do I still have natural, or has it expired?
Oh, I think you do. When did you get it? You probably got it. You probably got it.
I think
Yeah,
sometime after May 15th.
yeah, you still got it. You got till the 21st. You're good.
Okay, I can still support this then.
Yeah, good. So, so that's why physics is applied math, and then chemistry is like applied physics. So a lot of chemistry deals with a lot of stuff in terms of we start like building the blocks higher. So whereas in physics we use things like the Schrodinger equation to describe what we call wave functions, like how like the hydrogen atom like exists. Chemistry then like zooms the picture out, and it's like, okay, I'm gonna assume we don't need to deal with all the wave functions as much, and we're gonna deal with molecules, which are like building blocks of using hydrogen as like building blocks. Anything below chemistry isn't a science. Yeah, I mean I would agree, but I would start some fights with some biologists. I like chemistry. Chemistry is cool. Yeah, chemistry is dope. So chemistry takes a lot of physics concepts and applies them to, for instance, substances and chemicals and whatnot. That's what they do.
Also, why is there something called biochemistry?
So biochemistry. Biochemistry is a blend between biology and chemistry. It
talks about life and chemicals.
So biology, this is kind of new. I usually just see it's like this. Biology is applied chemistry because biology takes the rules of chemistry in terms of like, acids, bases, molecules, and whatnot, and it applies it to living things. So then we start zooming out even further, and we're like, okay, I don't care about the individual sodium hydroxides or whatever. I'm now going to talk about these as like whole systems, and this is where we start talking about organs and all types of cool stuff. Yeah, DNA, exactly. Right. Yeah. So that's why we say biology is applied chemistry. Biochemistry, I guess, is kind of more nitpicky. It's in between the two. Yeah, exactly. And then so biology is like the study of living things, right? So then we can go even further up, which is psychology. Which psychology is cool. It studies how like the mind works. So now like we're zooming out even further to like how humans behave, and like it's so cool because like humans are a collection of biological organs. These biological organs are a collection of different chemicals and chemistry, and these chemicals and chemistry are a collection of wave functions in physics, and wave functions in physics are just fancy integrals for math. So everything like stems down eventually to math. Like the whole world is math at the end of the day. You want to get in the most pure form. But in terms of like things that make the most sense to people in the real world, they tend to be the stuff up here, like for your average person. Most people understand psychology. They understand I'm happy when I eat ice cream. I'm sad when I don't. That's some psychology. And there's science to it, per se. Psychology is interesting. Yeah, I have a lot of friends that end up going into psychology. It's cooler when you start seeing like psychology like at the graduate level. Psychology at the undergrad level tends to be like some bullshit major that a bunch of like just cheerleaders and frat boys go into because it's easy. But it is actually very cool and complex once you start getting to like the graduate level of things. Like they do some really cool experiments, and it's cool to see how the human brain like. And then if you want to get above that, social sciences such as history, I don't know, female studies or something, whatever, like English writing, those are all big picture opinion pieces on like psychology, what it is, on like how humans interact and stuff. So yeah, a math and philosophy course, yeah, that'd be pretty cool. Yeah. Anyways, yeah, this everything's related. But at the end of the day, math is king. What'd I say? It's cool.
Right.
So yeah, that's pretty cool. Yeah. So yeah, to answer your question, Riplaw, AP Physics is this is what it is. AP Physics 1 specifically.
Algebra based.
It's algebra based, yeah, which means that the math that it uses is only algebra. There's also different types of math. There's calculus, there's linear algebra, there's all types of stuff, but really the full physics that you end up using is more calculus based. But yeah, so that's what I did. That's That's a pretty good. You know, I'm gonna count that as very interesting, right? Yeah, that's pretty cool. I'm gonna count that as that was a good question for.
Well,
I'm gonna count that as a question for you and Riplaw, dude. That's pretty good. I appreciate that one.
for me,
Yeah, I'll give it to you as well.
what kind of a question did I even ask?
You asked how math and science and physics are all related. I will teach you some physics.
Yeah.
Let me just make sure I can get through everyone's questions, and then I can teach you some intro physics. But I think that's very cool. How much stats do I know? I know a decent amount of stats. I've taught AP statistics. Yeah. I know a decent. I love stats. I know Noise doesn't like stats.
Statistics, seriously.
Yeah, dude. XDViz says AP Physics Exam 1 was so easy this year. Lol. Was it easy? Dude, I don't think it was. Dude, some of the people on my TikTok here, I'll show you. My TikTok was too funny. Was it TikTok.actual? Pull it up. So I do tutorial. If you don't know, I do tutorial videos on TikTok. Some of you guys here on TikTok found me through this, so that's where it came from. Was it this one? Yeah, here we go. Yeah. I did like a 1D projectile motion video here, and where was it? This guy, he said, "Oh no, couple hours too late." I was like, "Don't worry, I got tons of videos." And he said, "Not like it would have helped the FRQ like death." Apparently, the FRQ was tough.
FRQ?
Free response question. I said AP Physics 1, and he's like, "Yeah, I just took it yesterday." Cry face. So yeah, XDViz. Apparently these people didn't have a great time. D score, yes, that's all you need to do. That's cool. Do you remember XDViz? What type of questions were they? Were they like basically like spring questions or like what? What were they doing? Curious. I always like seeing like the comments on my TikToks when people, you know, talk about like. Okay. All right. Let's see who else we got for questions. Teacup's asking the Matrix rank of this. Dude, Jesus Christ, Teacup, dude.
That's dope.
Also, so could you teach me physics maybe Saturday, maybe?
Yeah, we can maybe go over that. Yeah, could teach you basic.
Or could you also talk to me on Discord so I can talk to you?
Yeah, for sure. Yeah, no, I'm gonna do it. What the hell is a Z course? Z score, dude. You know what a Z score is? Okay,
Wait,
what
what's a
is?
Z-score?
Good questions. Good questions. I'll go over at some point. My friend took both physics C, E, and M, and mechanics, and he said that he thinks he got a 4 on one and a 5 on the other. That's good, dude. Nice.
That's dope.
4s and 5s will get you credit usually. Most schools. Is there an actual proof for the Irwin model? Someone asked on YouTube. That's cool. What is the Irwin model? Let me check that real quick before I go into this. I'm just curious. What is the Irwin model? I realize I'm gonna start getting people who are gonna like start. Irwin Data Modeler is a computer software for data modeling. Okay, that's something else about the Irwin model. What is the Irwin model, Mohammed? You're like, I don't know. Are we talking about like? Oh, Schrodinger's first name was Irwin. That's cool. I didn't know that. They have a movie about him coming out, don't they? Is it Schrodinger? What's the movie coming out? Mainly rotational motion. Dude, there's some like movie coming out about like the Manhattan Project. Oh, it's Oppenheimer. It's Oppie. Oppie's cool. Oppenheimer's cool guy. Yeah, this not Operation 4. This is another. This is a cool guy. Oppenheimer. Oh, is Cillian Murphy playing him? Dude, that's great. You guys want to talk? Yeah, you want to know about like a physics badass? This is one of them, dude. Oppenheimer. Oppenheimer's a very cool guy. He ended up creating the. I think he was the lead scientist on the atom bomb back during World War II.
But you know, I really don't know any actors in movies.
Oh,
I
it's
just
okay.
watch them.
Yeah, no, it's okay. It's okay. You don't have to know one. Cillian Murphy. He was in Batman. He was in Peaky Blinders. I forget what else he's in. He's in a bunch of stuff. He's good. Emily Blunt, Matt Damon too. Whoa, Robert Downey Jr. Oh, there's some really cool. I gotta see this movie. When does this movie come out? Oh, July 21st. Wow, a very long time for now. Okay, cool. Oh, the Irwin model of the atom. Oh, that's cool. Yeah, let me check. Let me. Irwin model. Atom. Oh, the quantum wave model. Oh, yeah. Yeah, it's just cool. We get into like what, like the plum pudding model. There's all these like different models for how atoms exist. Yeah, here we go. I love this. Yeah, this is awesome, dude. This is what they're talking about. These are all different ideas that these people came up with. Yeah, Robert Dalton, J.J. Thompson, I think, something Rutherford, Niels Bohr. Yeah, they had all these different ideas for how, because we can't really like see atoms. I mean, we can with like different scanning electron microscopes and whatnot. But these were all, they came
Also,
up with like ideas for how atoms work. Pretty cool. Their actual
wait,
proof.
that's
I
all?
don't know if there's actual proof.
That's all.
What's up? E?
I've seen like some of these models.
Yeah, I'm sure you've seen them in your science classes, right? They talk about this.
Yeah,
So
I've only seen Thompson, Rutherford, and Bohr.
yeah,
Nothing
yeah,
else.
yeah. So these are like when we were trying to figure out like how atoms are, these are like the ideas we came. Have you heard of the theory of there only being one electron in the entire universe? No, tell me, dude. What?
But also, if it's Teachers Day, why don't you at least take a break today? What if you did that?
Oh, I can't take breaks, dude. I'm always running.
Run and push yourself
Here.
to the limits.
I
But
push
don't
myself
complain
to the
me
limit,
if you
dude.
get tired.
I will. All right, here. Teacup. You said you know how to do this. Come up and do this one then. Come up and do it. You can do this one, Teacup. I'll tell you straight up. Like, I don't know how to do this one. Dalton's model is the best because it's the easiest. Oh, okay, cool.
Maybe Noise will know how to do this.
Probably does. The one electron. I want to see this. One electron postulate.
Also, what are
Oh, John Wheeler's a
eigenvectors?
cool guy. John Wheeler, I think, was at. I think he went to University of Texas. I think this guy. Hopkins, but I think he taught eventually at University of Texas. Yeah, that's how I know him from. I remember our building was named. Wow. Okay. Lyman, I know why all electrons have the same charge and mass because they're all the same electron. What? Yo, that's pretty cool. Oh man, this goes on the whole like the whole universe is a matrix and everything's a lie. Yeah, that's cool. Teacup, it is your question. I'm pinging you right now, dude. Come to your question. Come to your question. Inviting you to speak. Teacup, it's your time. You're deafened though. What's up, Teacup?
Yes, hello.
Yes. All right, cool. Here's your question. What is the matrix rank? You know what matrix rank is?
Yes, it's
What
the
is it?
number of rows that are not zero
After what?
after echelon form.
After row reduced echelon. Yes, Ethan. Noise does know how to do this question. How do you do this question, Noise? Tell us. Tell the crowd. I mean, I think I know how to do this with a calculator. Wait. Stop. There you go. There's a calculator. Yeah. Yeah. Noise. Yeah. How do you do this one? I think this one we put into like the matrix here, right? This is what? This is a 4x4. I say like 4x4 was negative 219. Dude, these numbers, bro, dude. Like, who hurt you as a child, dude? Why would 17 negative 6 49 81 negative 2 1 462 460. 109. Oh, okay, finally done. Jeez. Yeah, you can put a whole matrix in a calculator. Yeah. You guys didn't know that? Yeah, you can do this. If you go to second matrix here, and then you go, so these are the labels of the matrix. These are like A, B, C, and D. And if you go here over to edit, you can create them. This is super useful. If you ever need to solve like linear equations, like systems of equations, you can do them right here. It's very cool. Okay. So I think we said, what was it? We're gonna do some math on this thing. What was it? It was row reduced echelon form. So I think that's I think it's REF. Let's try REF. REF, and then you can select matrix A here.
REF is reduced echelon form, and REF is.
Oh, okay,
row
cool. Here we go.
echelon form.
Here's our matrix. Look, yeah.
That's a very nice number there.
Can I not scroll over though, dude? Bro, what? Doesn't want me to go over. That's kind of.
Yeah.
Wait.
It's too long. The decimals.
You know, here's the cool thing. I think I can store this into another matrix. I think I can store this into matrix. Yeah, cool. Now watch this. Now if I go to second matrix and I go to edit matrix B, it'll show it to me. There we go. That's what I wanted. Okay, cool. So this is the matrix apparently. Oh, wow. Look at that. That's actually quite beautiful. Look, it's 1 all that, right?
Not bad.
1 all that, 1 all that, and then just 1. 0, 0, 1. Very cool.
So it's.
The dimension vector space generated by its columns. Yeah, so what's the dimension of this? Is this a rank 4? Is this a rank 4 matrix? Because we have 4 non-zero columns, right? 4 non-zero rows. Y'all tell me, my linear algebra is like a little actually, and here's another thing. I want to see if I can do the RREF. Oh, yeah. Wow, that just perfectly diagonalizes. Wow. That's a perfect diagonals. Wow. Yes. Okay, so that's a rank 4. Yeah. All right, cool. Yeah, everything here has 1, 2, 3, 4. Everything has a number in it. That is a rank 4 matrix. Nice. And here's actually a good like little follow-up question. Like, why do I care that the matrix rank is 4? Like, that's cool, but like what's the point of that? Why do I care that the matrix rank? Like, what is the physical significance of this? This is a good question that comes back to what Ethan was talking about, like right with physics and chemistry and whatever. Like, this is a mathematical concept that the rank is 4, but in the applied world, like, well, what does it mean?
Wait. Is it like the solution?
Okay, let's see. Matrix.
It's like
Oh my god,
unique
what is happening?
solution. Maybe it's.
I think OBS. What was this? This was. Okay. Why is hitting anything?
Oh, did it tell you if it's a system of equations? I totally did not look this up.
Matrix rank significance.
Oh,
I
I found it. Here, you ready for this?
Yeah.
It is useful in letting us know if we have a chance of solving a system of linear equations when the rank is equal to the number of variables.
Okay.
And it's also used in communication and stability assistance and more. And like vector stuff.
That what? Yeah. Back.
Math.
Okay, there we go. OBS was active.
Oh, I have my final exam for English on Monday.
English? Oh, okay. Be okay for you. Right?
No.
Okay, in control theory, they say control theory, whether a linear system is controllable or observable. Okay. Gives the bounds on the bunch of stuff. The number of solutions of a linear. Okay. System is inconsistent if the rank of the matrix is greater than the rank of the coefficient. Okay. Oh, you know what they talk about? This is like unique solutions. I really like this. Yeah. Okay. Pretty cool. Yeah, very cool. So
We did it.
no. For instance, if I had if I had like a set of equations, like let's say for instance, like x times y is equal to 5, right? For instance, there's not a single unique solution because you could have, for instance, x is equal to 10, y is equal to 1/2. That would satisfy this equation, right? Also, like 20 and a quarter. These are all different solutions. So, rank is a cool way of saying for my specific variables, is this like the only solution, or they're yeah, that's cool.
Huh.
I like that. Yeah. This is where linear algebra comes in handy with stuff. Okay. Nice.
I think like the day before my math exam or like the last office, I'm just gonna ask you like a review question on something.
Yeah, no, please do. Yeah, if you have a math exam coming up, yeah, like let me help you out with your math. Totally
Teach
down
me
for it.
on factoring.
I got you, bro.
Okay, bye bye.
All right, good to see you. All right, Rip Law, what's up, dude? Where's Rip? Rip up here. Inviting you to speak. You got some circle stuff you're doing here, Rip? Yeah. Huh? I heard you for a second there, Rip. I heard. Oh, he's gonna reach. Yep. Invite you up. There you go. Rip Law is now a speaker. Who needs to fix their like state? No. Oh, is your mic not working again? I feel like it was just working, Rip Law. Weren't we just talking with you? Bruh. It's okay. Here, we'll do it over text. It's okay, Rip. All good. Okay. Radius of a circle is 4 feet. Okay, that's R. What is the circle's area? This is kind of a cool question. Do you know what the area of a circle is equal to? Okay. There's an equation for this. There's an equation for the area of a circle. Typing. Okay. Yes, pi r squared. Yo, thank you, Kale, dude. Yeah, you're right, dude. Yeah, it's all good. So the area of a circle equal to pi r squared. Very good. Yeah. This is area is equal to pi, and then this is the radius squared. So in this case, the radius is the distance from the center of a circle to any point on the edge. It's actually like I think the definition of a circle, right? Is that it's the set of all points that are the same distance from a center point. That's actually like how circles are like defined, right? Yeah, in this case, and pi is actually a very cool number. It's what do we say it is? Indeterminate or irrational, sorry. That's what it means. Where it has like infinite digits, 3.1415926. Does anyone know any more digits than pi? You've never seen pi on a question? Pi is very cool. Yeah, pi is a constant, but it is. But it's an irrational number, which means like it has like an infinite number of digits. I think if you go to what is it? Go like there's a whole Google thing where like how many digits are in pi, dude. It's gonna say like infinite. So you can't actually write down all of pi. It's an irrational. Yeah, the digits go on forever. I think you can say like all the digits of pi. So far, dude. Yeah, here we go. Someone has made like a giant. Yeah, here's the first 1,000. Do we want the 2 million digits? Oh, someone hasn't done that. Or it doesn't. Yeah. Anyways, yeah, pi is cool. Pi is there's a jump. Yeah, if you put your phone number, it'll tell you what digit of pi your phone number is at. Oh, that's so cool. Wow. Yeah. Okay. Yeah. This it's a constant, which Riplaw, you guys end up approximating. We just say it's like 3.14. Oh, what's up? I heard
Can
someone.
you hear me?
I can. There you go. What's up? You got your mic working? Cool. So in this case, yeah, we're not gonna write out all the digits because that would take forever. So we're just gonna say 3.14. And so in this case, this is A is equal to 3.14, and then you have to put the radius here. The radius here is 4. Which, you know, you can use a calculator to, because pi is, you know, not the nicest number on our heads. So yes, that's going to be 3.14 times 4 squared is just 16. And so you end up getting 50.24. And then this is an important thing, are units. Yeah, unless you're an engineer, then you say pi is equal to 3. Yeah, no, dude. That's like the people that say,
Without a calculator.
how can you do what, sorry?
How can you do this without a calculator if you don't got one?
Oh, you kind of need a calculator because well, I mean, you could do this by hand. You could. You just have to remember how to multiply things, right? So 4 squared is the same thing as 16. Do you know that? You know 4 squared is equal to 16?
Yes.
Okay, cool. And then we're just multiplying it by 3.14. Do you remember how to do this? This is kind of maybe a long lost art. Like, some people forget how to do it. Yeah. Do you know how to multiply these things together? Do you know how to do this by hand?
Yes.
Okay, good. This is just like 6 times 4, 24, carry the 2. 6 times 1 is 6, plus 2 is 8. 6 times 3 is 18. And then it's 0 here, and then 4, 1, 3. Good. 4, 12, 1, 10, 1, 5. 50.24, right? And that's the same thing we had on the calculator.
Okay.
50.24. That's how you do it by hand, okay? But all right, that's a cool thing. The area of a circle. There's another thing you should know. Do you know what the circumference of a circle is? Have you seen that word? Do you know what circumference means?
Yeah.
Okay. Circumference means like the perimeter is what it is. So this is basically like the distance it takes to go around a circle. Okay. And what you learn that equation is, which is C, we learn that's equal to 2 pi r, or another way to write this is pi times d. You know what d is? We talk about circles. Yeah, good job, Barner.
I'm not sure.
Okay, d is what we call the diameter. The diameter.
Oh, okay.
The diameter is always going to equal to twice the radius. That's why 2r becomes d. The diameter is this whole thing. The whole thing's the diameter. So there's actually a cool thing here. Because you said you've never seen pi before. Pi is like what I use to say as evidence that we're living in the Matrix or something, or that this almost be like a simulation. I kind of like my explanation. Yeah, it's because we know that the circumference of a circle is equal to pi times d. So the ratio, we say, so the circumference divided by the diameter of a circle is equal to pi. Okay? These are two real things, right? You can go out to like any sort of circle that's in the world, right? Such as, I don't know, like a cup or a beach ball or I don't know. There are a lot of circles. So there are a lot. You can go out into nature, right? And you can see a circle, and you can measure, for instance, how the distance it takes to go around the circle, right? And then you could also measure, for instance, the diameter. You could measure how wide that circle is. And if you divide those two numbers by each other, you will always end up getting this number called pi, this ratio. And this number pi has an infinite number of digits. So we, as like very intelligent human beings and whatnot, have created this beautiful thing called math with numbers, but it can't be used to describe the ratio of the circumference of a circle to the diameter of a circle. Like, those seem like two very basic things, you know, to measure the distance around a circle and the distance to go, you know, straight across the circle. It should be a nice number if math is correct, right? But it turns out it ends up being this infinite decimal irrational number called pi. So I don't know. To me, that's like very cool. I think that's a really cool thing about pi. Pi kind of like proves that we as humans we don't know everything. You know, apparently we don't know how to measure. We don't know how to describe the ratio of the circumference of diameter by any. So we had to like kind of come up with a fudge factor. We're just like, okay, we're just gonna call it pi. It's cool. Yeah. Very good question. Cool question, Rip. Yeah. Well, you know, this isn't the last time you're going to see pi on a math question. I guarantee you that. So it's good to get company to it now. All right. Let's see. Who's the next question we got coming up? We got Bob. Bob, who has a new calculus teacher. That really sucks when they do that. They like mid semester, dude. Like, come up to the stage, Bob.
I had that once where they switched my teachers.
Noise says, I remember in elementary school, they used to measure the circumference by, a piece of string, curving around, or then cutting it and measuring its length. Yeah. The cool thing is, like, you'll never get to an exact number with that length. I think that's super cool. Oh, wow. Oh, is this a related rates question, Bob?
I don't know. It just looked difficult.
I see, like, tank, and I see rates. And so this to me, like, you know, this starts to scream related rates to me. I start to think. Okay. Cool. Let's see. All right. A horizontal cylindrical tape has a cross-sectional area of this at a height x meters above the bottom when x is less than 3. That makes sense, because if I plug 3 into here... Well, no, it doesn't make sense. Okay, whatever. The volume between heights A and B is that. Okay. All right, so let's try to like describe like what this thing. Let me see. Negative. So it looks probably something like this, I imagine. This is the area, and then this is as a function of x. Pi. Okay, but it goes through 0 actually. It does like this. And yeah, where's that going to equal? That's when. Oh, okay. It's when x equals 6. That's kind of cool. I'm just graphing this by hand, Bob. This is the area, and this is as a function of x. Okay. Now you know for calculating the volume of something, right? Volume, like for instance, in the case of a rectangle, right? It's length times width times height. Where this is like what we could call like the cross-sectional area, or CA, right? So if I have, right, like some area, then I multiply it by the height, I'll get the whole volume. That's what they're saying here. They're using this as like, for instance, like DH. Oh yeah, because X is the height. And so A here is what we call the cross-sectional area. That would be this. Yeah. Cool. Excellent. All right. No, that's not. Okay, find the volume at heights between 2 meters and 3 meters. Okay. So, I mean, this is just plugging in for between height A equals 2 and B equals 3. See why that is? I hate words. Noise says, I hate this part of calculus. I hate words. I'll agree, dude. Sometimes I get to, like, certain questions, and I'm like, bro, why are there so many words on this?
Like, wait, what's that meter squared thing?
Good. Meter squared is just a unit. That's the units.
Oh, okay.
So remember area, right? Area is equal to like units squared.
Yeah.
Right?
Oh, yeah,
That's all it comes from. Yeah, so don't worry. This isn't a variable.
Okay.
Remember, everything is meters at the end of the day. So yeah, if they want the volume, right, we're just integrating the cross-sectional area between 2 different heights. Okay?
I can do that.
Yeah, you know how to do it. That's easy. Okay. Suppose the oil is being pumped into the tank at a rate of 50 liters per minute. Oh, ew. Liters and minutes? Oh, man, I'm going to have to do the conversion for, like, cubic meters and... Using the chain rule, okay, dx dt is equal to dx dv dv dt. At how many meters per minute is the height of the oil of the tank changing expressed in terms of x, where x is yeah, so many words, noise. There's so many words. Okay. Okay. Oh, oil's being pumped into the tank. Okay. At how many meters per minute is the height of the oil of the tank changing? Okay. Okay, so they want to know dx dt, right? Which is dx dv dv dt. Okay. Okay, so we need an expression for the volume, right? Oh, that's where we needed this. Right?
Oh.
Oh, or that's where we're going to need this. Okay. So, all right. Volume, right? That volume at a height x is going to be equal to the integral from 0 up to x, right? We're going to go from 0 up to the height x of the cross-sectional area dx. Does that make sense?
Yeah.
Okay. So a of x in this case is 4. So I'm gonna pull the 4 out. It's 4, and then it's 6x minus x squared, right? All this dx.
Yeah.
Okay. I can integrate. So that's gonna be 4 times. That's gonna be 6x squared over 2 minus x to the third over 3. Then that's from 0 to x. So plug in x, plug in 0. We don't care about the 0, right? 0 goes away.
Yeah.
We don't worry about that. Okay. So just plug in x for x, whatever, right? V of x is going to equal to 24x squared minus 4x cubed. All right? That's the volume of something as a function of x. All right? Now, what's happening is we have, I'm just going to say this is our right? And the volume of x is we are increasing the volume by a certain rate. And that has to do with the oil being pumped in, right? Because I'm pumping in a volume of oil into my container, and I'm doing so at this rate here. So what I can say is that dv dt, right? The change in volume of the change in time, that's equal to 50 liters per minute. Okay? Problem here is that all our volumes here are in terms of like meters cubed. Do you see that? Like is our volume, whereas this is in liters. I don't like that. So you need a conversion factor between. Which I think 1 meter cubed is equal to 1,000 liters. Correct me on that. That's right. 1 meter cubic. Yeah, 1 cubic meter is 1,000 liters. There's a nicer way that works. You could do but this is a conversion you should know. Okay. So instead of it being 50 liters per minute, I'm gonna say it's 50 over 1,000, right? So it's gonna be 0.050 meters cubed equal to 50 liters. You understand where that came from? Let me know if you don't.
Wait. Okay, wait, can you repeat that?
Sure. So I have here some dv/dt, the change in volume over the change in time. I have it in liters per minute. But everything else I'm doing in terms of volumes of this tank and the height of this tank is all in terms of meters. Okay? So what I need to do is I need to convert liters into meters cubed. These are both units of volume, right? What I know is 1,000 liters is 1 meter cubed. So that means 1 meter cubed over 1,000 liters, right, is going to be equal to how many meters cubed over 50 liters, right? And so if I move this over, right, this is 50 over 1,000, which is equal to 0.05.
Oh, yeah, I see now.
Good? Okay. So I'm going to replace this with 0.05 meters cubed per minute. Okay, that's dv/dt, right? They want to know dx/dt. They want to know how much is the height changing. X, remember, is the height. So we can, this is where like you can just blindly use calculus here, because you know that by the chain rule, dx dt is equal to dx dv times dv dt. You see how these cancel out?
Mhm.
Yeah, good. Okay, what's up, Sasuke? dv dt, we know, which was given to us, right? That's the 0.05, right? Okay.
Uh-huh.
This I'm going to go away. I'm going to be like, cool, this is 0.05 meters cubed per minute, all right? Now I need dx dv, all right? Which we got an expression for v as a function of x, right? See how v was equal to 24x squared minus 4x cubed?
Mm-hmm.
Okay. I'm going to implicitly derive both sides here because that's just going to be easier. Instead of like rewriting everything in terms of x and then doing stuff, this is going to be dv is equal to 48x dx minus 12x squared. Okay.
Mm-hmm.
All right. I can pull the dx out, right?
Yeah.
This is the same thing as all of this dx, right? So then dx dv is going to equal 1 divided by 48x minus 12x squared. Right? If I move this over and then move this over, right?
Uh-huh.
So now I can plug this into here. So I get dx dt is equal to 0.05 over 48x minus 12x squared. And then that's going to be meters cubed. Sorry, that's just going to be meters per minute. Because dx dv, right, this is going to have units of meters over meters cubed, because x was just a height in meters. Volume was, v was a volume in meters cubed. So this is going to be 1 over meters squared.
Okay.
You have 1 over meters squared times meters cubed, right? This is 1 over meters squared. And that's just going to get you meters per minute, which, that kind of makes sense. That's the height. The height is changing this amount of meters per minute. But do you see how it's dependent on what height you're at?
Mm-hmm.
That's where the x comes from.
Okay.
Cool.
Mm-hmm.
Okay. How long does it take to fill the tank to 3 meters? Starting from a fill level of 2 meters. Okay. What we do is we figure out what the volume is between 2 and 3, right? So,
Do
instead
I
of doing
integrate the dx dt?
good. Yeah, oh yeah, maybe you can. Oh, that's actually pretty cool. Yeah, let's think about that actually. No, that's actually pretty cool. Yeah, you have the xdt, right? And you want to go from 2 to 3? That's kind of cool. They both should work. Let's check it. Okay, so 48x minus 12x squared, right, is going to equal 0.05 dt.
Mm-hmm.
Okay, then you're right. I'm going to integrate this from a height of 2 to 3, right? And this is going to integrate from t0 to t, or we can just say like 0 to t. Okay, this is going to be the time. Yeah, no, this is cool. This actually probably works. So this is 48x squared over 2, so that's 24x squared minus 4x cubed, right?
Uh-huh.
From 2 to 3 equal to 0.05 t, right?
Uh-huh.
So, yeah, plugging that in, that's 24 times 9 minus 4 times 27, all of that minus 96 minus 32, right? I do not know what 9 times 24. It's 240, but minus. My head is. I could do this. All right, let's do it. 9 times 24. Yeah, 260 minus 4 times 27. Good. Okay. Then minus, we're gonna say 96 minus 32. Okay, cool. So that's going to be 44 equal to 0.05 t. Then we're going to divide that by 0.05.
Uh-huh.
and that's going to give me 880 minutes. That's a key thing. So it's time, but let's remember that our unit of time when we did DT, that was in minutes. That's where that comes. Yeah. Well, is that the right answer? Do we know if that one's right?
I don't know.
Well, another way to check it is I could figure out the volume between 2 and 3. I could do this, right? From 2 to 3, and then just divide it by 50 or 0.05, which I think that's literally what we did. Is that literally what we did here? Yeah. Yeah, see how we did the same thing?
Yeah.
2 to 3, and then we divided it. Yeah, same answer. Should be correct. I think it is.
Thank you.
Nice. Yeah, that's kind of a hard one.
Yeah.
Is that what your teacher's giving you for your test? Is that what's coming up for you, man, dude? Do you have to do that shit?
I don't know.
I hope
That's just
not.
like homework problems.
That's a homework question?
Yeah.
Put you guys through the ringer, dude. All right.
Thank you.
Well, yeah, you're welcome, dude. Very welcome. All right, Equity's got a question. What's up, Equity? Equity, chat, where you at? Equity. Equity. Me and Equity are playing like the longest game. I think the problem is like we get too much time to think about our moves. Yeah, this is us on this.
At least 1 month.
Yeah, it's at least this. Yeah, it's a very complicated game, and honestly, like I have to like really go through because I forget what pieces are protecting what. I'm like, all right, wait, where am I at this game? We should probably just set a time aside and just kind of like blitz it out. Yeah, I'd probably lose on. All right, where is Equity's question? I'll pull it up anyway. Equity shows. Because we're gonna do Roblox today. Roblox bonus game. You guys want to pick like some cool role playing game to do again? I really liked the what did we do last time? The daycare or something? Or no, we did hotel.
Camping.
We did camping. Yeah, we did the camping. Time with that. All right, let's see. Equity will show up while we do. All right. Says a ship is 130 meters away from the center of a barrier that measures 180 meters end to end. What is the minimum angle the boat must turn in order to avoid hitting the barrier? Okay, that's cool. So this boat is like going this way. Like, please don't hit this. Don't be the Titanic. I used to be obsessed with the Titanic when I was growing up. I had all the books. I like read all the documentaries and stuff. Isn't too bad. It's just trig. Okay. So we want to figure out probably this angle right here. This is going to be equal to theta, like so that we can clear this barrier and not hit it. And yeah, some of the work's already been done for us here, right? We know that the barrier is 180 meters end to end, but we only need to clear 90 of it because we only got to clear this top half. We could also go this way. Don't clear this 90. And we know we're 130 meters away. Okay. So Ethan, this is a good one for you, bro. Ethan, do you know how to do this one? Pretty good one. It's a right triangle. We love right triangles, right? This is 130, and we're trying to figure out this angle theta. Anyone know how to do this? This is trig. Someone was asking me to do trig during the last lesson. Yo, can you do some trig? This would be some trig. Okay, so what we're going to do is use our trig identities. SOHCAHTOA. Remember, this is sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tangent is opposite over adjacent. Oh, and there's always angles in here. So in a triangle, if this is the angle theta, this is always the hypotenuse. The hypotenuse is always the side of the triangle that is opposite the 90-degree angle. Okay, it's always going to be the biggest side too. All right, and then depending which angle you're looking at, the opposite is going to be the one opposite the angle. We're going to call that opposite, and the adjacent is going to be the other one, which is adjacent. Okay, there we go. So in this case, I'm trying to figure out an angle. I have an opposite and an adjacent. So I'm going to end up using TOA, tangent, that has opposite and adjacent in it. So that's going to be the tangent of theta is equal to the opposite over the adjacent, which is going to be equal to 90 over 130. So the way to solve for tangent here, you don't divide by tangent. A lot of people think you just do that, it just goes away. But no, that's wrong. Tangent is a function. The way to do that is to take the inverse tangent. Because what inverse tangent does is inverse tangent gets rid of tangent so that you're just left with theta, the angle we're looking at. You can do this on your calculator. Pull up the TI here. This is going to be inverse tangent of 90 over 130. Sorry, 30. That's going to be equal to 34.7 degrees. Let's make sure I was in degree. I was in degree. Make sure you're always in degree. And there you go. That's your answer. 34.7 degrees. Nice. All right, cool. Okay.
You wanna review? You wanna talk to me about physics now? Like, give me a question on it.
Yes. Let's see. We're already kind of over time. Can I do it on Monday stream?
I guess you can.
Yeah, let me do it. Just because we're a little bit over already, and I want to make sure you guys have time for Roblox because then I do have to teach. Anyways, okay, cool. Thank you everyone for coming to office hours. Had a super fun time learning all with you guys. I hope you guys got something out of it as well. If you have any, questions about math or science or stuff that you haven't done before, please, come by the stream. I'll help you out. And we can learn some stuff. I learned stuff with you guys. If you ask like super advanced questions that I've never done before, like please, I enjoy learning as well. Okay. So, what we're gonna do now, if you guys are in our Discord, you know that we like to play video games afterwards. When we do all the after all the learning knowledge stuff, we play video games. So if you guys, today is Friday, which means we play Roblox. If you guys want to play Roblox with us, we're gonna do that on the actual gaming channel. Pull that up. Start streaming. Monday is our next stream, our next official stream. I'm gonna talk to Noise. Maybe we'll do a physics stream on Saturday or Sunday. I'll announce it where we can just kind of review through a physics exam and go through questions there. Oh, Noise, yeah. Oh man, I was gonna do part of your exam on the stream. I need to remind myself. Yeah, Noise. Let's find a time that works for you that isn't super late, right? And let's go through your physics exam. I wanna make prepped and but yeah, I'll announce that. Otherwise, our next stream is going to be Monday at 3 p.m. Pacific, 5 p.m. Central, 7 p.m. Eastern. So come by there if you have any questions and you want to learn some stuff with us. Here, I'm gonna end the TikTok stream. Thanks for watching on TikTok. We're gonna keep putting out more tutorial videos, so stick around if you guys want to learn stuff there. And Prism go. Okay. If you want to come play Roblox games with us, we're gonna do that in actual gaming. I'm gonna raid the channel right now. Feel free to hang out, come talk with us. Otherwise, I hope you guys have an awesome weekend. Have a great time. Enjoy some. It's Mother's Day on Sunday. Make sure you remember to do something nice for Mom. She's the reason you're here. So be nice to her. I gotta remember what I'm doing for Mother's Day. But yeah, if you guys want to keep hanging out, we're gonna go to actual gaming. Come play some Roblox with us, and otherwise, I'll see you guys on Monday.